Okay, geometers, here we go. Some more terms for you tonight, and hopefully we can just get through these notes quickly, and then we can use our definitions and theorems, postulates in a couple of proofs tomorrow to help you understand how you're going to use all this information that we're throwing at you. So let's go to your notes, and you have 5, I think, different angles that we're going to define. Some of these you've already seen in the past, and we'll just work with them from this point forward. Okay, adjacent angles. The definition's going to be a little bit strange to you. The definition is a pair of angles with a shared vertex and a common side, but they do not have overlapping interiors. Now, again, we're talking about definitions that are kind of bulletproof, that are going to definitely hold their water. So, examples, if you think about this angle, okay, this pair of angles ADB and CDB, they have a shared vertex D and they have a common side DB, but their interiors do not overlap. Those are adjacent angles. These would not be adjacent angles. They do not share a vertex. Their common interiors do not overlap, but they also do not share a vertex. Linear pair. Linear pair is an extremely important type of angles that you will use again a lot this year. And they're defined as two adjacent angles whose non-common sides are opposite rays. And we talked about opposite rays previously. So if you think about this, 5 and 6, they're adjacent angles. They share a vertex. I don't know if they don't really show it there, but if you look up where the arrow is, that's their vertex, okay? Their non-common sides, they have this common side in the middle. Their non-common sides are actually opposite rays, so they are called a linear pair. Complementary angles. Definition: a pair of angles whose sum is 90 degrees. Examples: we can have adjacent angles that are complementary, and we can also have non-adjacent angles that are complementary. They do not have to be touching. They do not have to be adjacent in order to be complementary. And likewise with supplementary. So supplementary, a pair of angles whose sum is 180, and we can have a linear pair. Adjacent supplementary angles are called a linear pair. That is actually the linear pair postulate. You will see down at the bottom. Very, very important postulate for your proofs this year. Supplementary angles can also be non-adjacent. Okay. Vertical angles. Vertical angles, again, another really, really important pair of angles you will use frequently, and that is a pair of angles whose sides form opposite rays. Basically, they form an X. 1 and 3 are vertical angles. 4 and 2 are vertical angles. Okay? So if you just want to look quickly at the theorem on the back, I'd like to start there tomorrow, but I do want to tell you what the vertical angle theorem is. It's really, really important, and it is vertical angles are congruent. Okay, that's the vertical angle theorem. Vertical angles are congruent. Really, really, I made it so big that I can't even see my exclamation points. Really, really important. That is the vertical angle theorem. We will start there tomorrow. Have a wonderful night.